Picture this. It's 1997, and Apple's just announced its Powermac G5 line. It's a transparent blue, or opaque beige, beast of modern computing. The PowerPC 750 in Apple's new machine is breaking the current Pentium 2's records left and right.
Apple Computer would like to apologize for toasting the Pentium 2 processor in public.
Between 70 and 94% if you're running by Bytemarks numbers. That's insane. Well, let's fast forward to 2003, shall we? And yikes. How did Apple get here? What was IBM's problem? Why does the corpse of this 8800 GTX still haunt me? First, we're going to need a bit of a history lesson. In 1991, Apple, IBM, and Motorola formed the AIM Alliance. Don't worry, that's not the only clever acronym we'll be running into today. Their goal was to develop a RISC-based ISA that would punch up to x86's weight class. Based on IBM's Power, or Performance Optimization with Enhanced RISC architecture, PowerPC, or Performance Optimization with Enhanced RISC Performance Computing, was the newest iteration of this multi-function, super-duper special sauce ISA that would make RISC more viable in more applications. Why they decided to go with 2 extra redundant words in the acronym instead of just calling it Power 2 is beyond me. Ridiculous naming schemes aside, PowerPC was actually quite different from the original Power ISA. At Apple's request, floating point instructions were added, presumably to help with compatibility concerns. On top of that, there was a machine state register, or MSR for short, which would allow the CPU to switch its endianness. This was incredibly important, given that the values of the CPU instructions read by the registers of x86 processors were usually read by the little or smaller value ends first. The PowerPC ISA, on the other hand, ran big endian values in its instruction set. So for the sake of developers and consumers not entering an inexorable downward spiral into psychosis, this MSR was introduced to allow processors to run in either little endian or big endian instructions by swapping bytes with a compatible motherboard. This allowed compatibility with things like Windows NT on PowerPC. That's right, Windows on ARM wasn't the first non-x86 Windows version with gimped compatibility and limited support. Shame on you, Microsoft. Shame on you. Going back to complaining about big cats rather than glass fixtures, time went on. Seasons changed, AIM broke up quicker than the Runaways, and Apple was sitting pretty with the performance crown in the late 90s, even releasing the first 64-bit systems in the consumer space. The G5 Powermacs. Yep, it's time to talk about the end of the Power Macintosh lineup. You see, these Macs were released around the time of the Gigahertz War, when chip makers like AMD and Intel were pushing their CPUs to break enormous speed records. With this, in hindsight, ridiculous dick measuring contest that led to the failure of the Pentium 4 in mind, Steve Jobs made sure to state during the G5's introduction that the scrappy little PowerPC 970 chip in these oversized cheese graters would reach 3.0 gigahertz within 12 months. Guess what never ended up being true? Yep. The reality was, the single CPU and eventually dual CPU G5 Power Macs amounted to not more than ovens and sexy aluminum chassis. And that was when they were running at 2.7 gigahertz. In fact, these things got so damn hot that Apple had to use these massive, chunky heat sinks to even keep them performant for long periods of time, as well as use clever airflow tricks like these pocketed side plastic panels on the interior. When that didn't work for your specific use case, they just slammed these gigantic liquid cooling loops inside of them, which of course eventually leaked all over the boards and failed very regularly, might I add. Side note, This is why, if you have no intention of maintaining a computer after you've purchased it, do not buy anything with an included liquid cooler, especially if it is as impossible to repair as these things were. Just look at what happened with the R9s that had the included AIOs, and you'll see why I put that in all caps on the script. Back to the G5. The limited amount of performance per watt of these devices wasn't the only issue they were facing. No, they just had to have even more reliability scandals. You see, the metal backplate that connected the 8 RAM slots on the main logic board, that's correct, 8. 2GB DIMMs weren't very common back when these things first released, would expand and contract in such a way as they were heating up and cooling down that they would just pop off of their soldering, and the system wouldn't detect any memory. These are $3,000 machines adjusted for inflation, by the way. Oh, that's not all. You see, not only was the G5 a power-hungry little guy, it also didn't have very great ways of managing that power. Due to a boneheaded oversight on IBM's part, the original single-core models of the G5 lacked key system regulation features, resulting in fluctuations in power draw and, thusly, the widespread chirping noise issue that was common in most pre-dual-core G5 machines. Other audio-related noise problems were noted, but these had mostly been fixed by the time the second revision of the G5 had rolled out. That's right, the second revision of the single-core version. That last one was especially annoying, since these things were so widely used by professionals in the audio space, where often they bought the liquid cooling models to reduce ambient noise. Huge mistake if you weren't paying attention earlier. Although these flaws were very much present in the earlier single-core G5 models, it is important to note that most of them were fixed by the time dual-core processors were chucked into these things. That's right, even the faulty, leaky liquid cooling loops. But by that time, it was late 2004. Apple was less than 2 years from abandoning PowerPC entirely. And there we have the crux of the whole G5 line. Timing. Only 3 years after these things were introduced in 2003, Apple had already moved on to greener pastures, and there were x86 Intel chips in pretty much every single corner of their Mac product stack. And at the time, these costed $2,000, so no wonder why Apple's consumer loyalty was somewhat shaky after that event. This transition to x86 brought with it better compatibility, better performance, and better efficiency than anything the later PowerPC lineup had to offer. Even PA Semi's supposedly more efficient G5 derivatives never made it to market in time. And this pipe dream that had flourished for over a decade finally disappeared like a fart in the wind. That's not to say that G5 was a complete failure. Keep in mind, these things were years ahead of their time as far as prosumer workstations were concerned. 64-bit CPUs, dual CPU systems in the consumer space, liquid coolers on the desktop. These things had I/O that would make modern enthusiast workstations blush. And that's what the G5 line was all about, wasn't it? Hulking, advanced, but ultimately costly, hot, loud, and quickly unsupported marvels of early 2000s computing. And for that alone, I think the Powermac G5 is worth being remembered. Maybe not the hero we deserved, but the one we needed. Either that, or it was just overpriced, frustrating hardware that was only justified by a partnership with IBM. I can't really tell with these things. Action Retro, please don't kill me. I know I've sinned.